All right, so in this lesson, we are writing equations for parallel and perpendicular lines. If you notice, you guys have some vocabulary terms. Parallel lines, we know that these are lines that do not intersect. We know that parallel lines have the same slope, and that's what we need to keep in mind here. Parallel lines have the same slope. For instance, if you look at the example, notice the slope here is 2. The slope here is 2. We know that these two lines are parallel. If we look at example 1, they want us to write an equation in slope-intercept form for the line that passes through this given point and is parallel to the given equation. So the first thing you want to do is identify the slope of the given equation. And we know that the slope is 3. From here, we're going to look at our steps. It says plug the slope into the equation. So here, my equation is y is equal to mx plus b, and I want to plug in the slope. So in place of m, I'm going to write 3. So I have y is equal to 3x plus b. Step 2 says they want you to substitute the given point for your x and y. And we know that the point is here, this 1, 7. So my point is 1, 7. I know that this is my x and this is my y. And I want to substitute this into my equation. When I do that, in place of y, I get 7 is equal to 3. In place of x, I have 1 plus b. Step 3 says to solve for b. So here I have 7 is equal to 3 times 1 is simply 3 plus b. In order to solve for b, I have to get rid of the 3 using inverse operations. So I need to subtract the 3 from both sides. Therefore, b is equal to 4. From here, I have my y-intercept and I have my slope. I can write the equation. And step 4 says write the equation. So I'm going to write it in slope-intercept form.
Teachers, please find this in.
So if I write the equation, I have y is equal to my slope, which is 3x plus 4. And this is the equation of the line, given the slope and the point. If you will, go ahead and work out the checkpoint. Down at the bottom, it says, note, be careful. Two equations may be the same line, so in fact, they are not parallel. We know that equations that are the same line have the same slope and the same y-intercept. For instance, if I gave you the equation y is equal to 2x plus 5 and y is equal to 2x plus 5. Notice that these two equations have the same slope. They also have the same y-intercept. So in fact, they are the same line and not necessarily parallel. These two equations are the same line. So please be careful of that when you're looking at equations. Identify the slope, but make sure they have different y-intercepts. In our next example, we're looking at perpendicular lines. And here we know that lines that intersect at right angles are called perpendicular lines. We know that perpendicular lines have opposite reciprocal slopes. They have opposite reciprocal slopes. And we're going to see that in our example. If we look at example 2, it says find the equation of the line that's perpendicular to the given equation and passes through the given point. So our first step, it says find the opposite reciprocal of the given slope. If we look at our equation, we know that the slope that is given is a -4. And I can make that into a fraction by putting a 1 underneath it. If I'm trying to find the new slope, I know that I need to flip what's given. So I flip it, and then I want to change the sign. So instead of being negative, it is positive. This is the opposite reciprocal. You take the given slope, you flip it. Notice I have 1 over 4 now. And then you take the opposite sign. It's positive. So that's step 1. Step 2 says substitute the new slope and the given point into your equation and solve for b. Here we know that our point was 4, 2. We know that this is our x and this is our y, and we have our slope. So we want to plug it into the slope-intercept formula and solve. So in place of y, we have 2, and this is going to be equal to m, which is our new slope, 1 over 4. This is going to be times x, which is 4, plus b. Notice we have to solve for b. You want to solve for b. When I simplify, I have 2 is equal to, and here I'm going to multiply this fraction times the whole number straight across. So 4 times 1 gives me 4 at the top and 4 at the bottom. 4 over 4 is simply 1. And this is plus b. From here, to get rid of this 1, I need to use the inverse, so I'm going to subtract 1. And therefore, b is equal to 1. Notice I have my new slope and I have my y-intercept. I can write the equation. So the equation of the line that is perpendicular to the given equation would be y is equal to that 1/4 x plus 1. And this is our answer. If you will, go ahead and look at the checkpoint. I want you to write an equation of a line that's perpendicular to the given equation and runs through the point -3, 5. Please make sure you follow the steps. Make sure you identify the slope in this equation and then write the new slope. Then use the point and the new slope to solve for b. All right, so from here we're looking at our last example, example 3, and they want you to determine whether or not the given equations are parallel, perpendicular, or neither. So if I look at these two equations, I notice that the issue is that they are in standard form and not slope-intercept form. If they were in slope-intercept form, I would easily be able to identify the slope. But I can't identify the slope, so in step 1, we need to write each equation in slope-intercept form. If we look at that first equation, we have x minus 2y is equal to 4, and we want to put it in slope-intercept form, so I need to solve for y. In order to do that, I need to get rid of that x. Since it's a positive x, I have to do the inverse, which is to subtract x from both sides. This gives me a -2y is equal to a -x plus 4. Notice that the variable is in front. From here, I need to get rid of that -2. Since this is multiplication, the inverse would be to divide. Notice that what I do on one side, I have to do to every term on the other side. When I simplify this, we know the 2's will cancel out. So I'll have y is equal to, and notice here a negative over a negative is going to yield a positive. And I can pull that 2 out and I'll have 1/2 x. Over here 4 divided by -2 gives me a -2. Now that the equation is in slope-intercept form, I can easily identify the slope as 1/2. If I look at that second equation, I need to solve for y. So my second equation is 2x plus y is equal to 5. When I solve for y, I need to get rid of that 2x, so I'm going to subtract 2x from both sides. This leaves me with y is equal to a -2x plus 5. And here, when I identify my slope, I know that the slope is equal to a -2. If we notice that these two equations, or these two slopes, if I put a 1 underneath here, I notice that there was a flip, and they have an opposite sign. So I know that this slope is the opposite reciprocal of the first slope. Therefore, these two lines are perpendicular. And that's example 3. If you will, notice the reminder at the bottom. If they have the same slope, they are parallel. If they have opposite reciprocal slopes, the two equations are perpendicular. And that's the end of this lesson.